Well, thanks very much, Ivan. I want to thank you and Prashad for the invitation to participate today. And we had a lot of great presentations this morning. And after I'm done, there'll be four other great ones. So we'll just spend a few minutes here talking about the realities in the current and future supply of coal combustion products and focusing primarily on fly ash. So, what's the reality of the state of supply today, and why are we in the state that we're in? We're going to spend a couple slides here talking about that. First off, it's important to remember that we look at these markets nationally and regionally, and the problems that we're experiencing in certain regions don't exist across the country. There are areas in the country that are doing just fine with their supply. There are other areas of the country that there's a significant gap between supply and demand. For decades, ACAA has spent its energies and resources on trying to educate folks on how to use all coal combustion products responsibly. And we're a bit like the dog that caught the car, that old story. We've caught up to the car. Now what happens? We've got to figure that out. Primary reason for the gap between supply and demand in these regional areas, demand has been increasing while coal fuel generation has been decreasing. We heard a lot about that this morning. As recently as about 8 or 9 years ago, coal was still fueling about 50% of the generation of electricity in the United States. Today, the coal fuel accounts for about 20 to 25% of generation. So we're about half of what we were only 8 to 9 years ago. Base load generation has declined. In some markets, it's been eliminated entirely. Base load generation is very important when you're trying to get concrete grade fly ash, if you will, because when the plants are running at a high capacity on a consistent basis, that's when you make the best fly ash. Now we see that coal plants are being used mostly in peak periods in very hot and very cold weather conditions, which means we have to gather that ash when we can get our hands on it and get it into the marketplace and into storage. So the coal plants are operating differently now than they had only just a few years ago. Some further reasons, in 2009, the U.S. Environmental Protection Agency started an attempt to regulate fly ash and other CCPs as hazardous waste in an effort to gain some regulatory authority over the management of these materials and disposal. This scared some of the utility companies that had been thinking about how they're going to use coal and going into the future. And they said, well, if they're going to regulate this material as a hazardous waste, and it's not the first time they've tried to do that. They tried to do it a couple other times in EPA in 1993 in the year 2000, and again in 2015, made determinations that coal ash in all forms does not warrant management as a hazardous waste. So that gave some of the utilities a little more reason to think about their future with coal. Another factor is, of course, many of the coal plants began to hit retirement here in the last 10 to 15 years. The coal fleet started to grow rapidly in the late 50s, 60s, and 70s because of a very significant report that came out in the 50s, which was highly respected among the utility industries, which said we were going to run out of oil and gas in the 70s. And the utility management during that time started to become more interested in building coal plants because of the prediction that we were going to run out of gas and oil, which couldn't have been more wrong, but that's how we got to build these plants. So a lot of these plants are 40, 50, 60 years old, and they're in a situation now where they just are about due to retire, and retrofitting these plants that are 40, 50, 60 years old to meet EPA air standards and other standards just doesn't make economic sense. So these plants were expected to be retired in this period of time. So that wasn't a surprise. In recent years, we've seen combustion stream injections making some fly ash unsuitable for use in concrete. Probably the best example is the injection of activated carbon for mercury control. In many cases, this activated carbon, which is much finer than the carbon we find unburned in coal ash, this material at very low levels can make it impossible to entrain air in some concretes. So we've seen other injections being used in power plants because the power plants must comply with clean air standards, and in doing so, these injections become necessary in some plants, again, rendering some fly ash unsuitable for use in concrete. We're learning how to overcome that as an industry. We found a number of factors which can be mitigated. So even with some injections of things like activated carbon, we can use the material in concrete, but it does affect the availability of some of these materials. Of course, as fracking started to spread across the country, we saw a rapid increase in the supply of natural gas. Of course, that meant that natural gas prices would decrease with this dramatically increased supply, and in some cases got to levels which were unsustainable. In late 2015, early 2016, natural gas went down to about $1.70 per million BTU. And in that process, we saw a number of natural gas companies go out of business, and some go bankrupt because it's not sustainable at $1.70. So when you're looking at gas prices, a more realistic price for the marketplace for anybody to have a sustainable business is in the $3 to $4 range as a minimum. And of course, finally, affecting our state of supply today is the fact that many of the environmental activists have targeted fossil fuels as the great Satan, and are doing everything they possibly can to shut down coal, natural gas, and oil as far as the fuels for power plants. So these are the factors, the primary factors, not all of them naturally, but the majority of these are the main ones that are affecting the supply of fly ash today. So the reality is that we have regional shortages, regional gaps between supply and demand, and with fewer plants running, that means if your particular power plant does not satisfy the supply for your market, the next available power plant may not be 50 miles away as it was 10 years ago. It may be 500 miles away. And when you start talking transportation, that starts to cost a lot of money, and it raises a lot of headaches for the logistical management of the material that you need into your market. This morning, Tyler Lay did a great job, and he mentioned that there is a lot of fly ash not in use. And I think this slide will demonstrate that with some hard numbers here. And this is one slide that you ought to pay, I think, close attention to. Each year, we dispose of millions of tons of fly ash going into disposal rather than into beneficial use. Well, why is that? Two primary reasons. One, dislocation. That means the ash that is in excess supply in one market, getting it to a market that has a shortage of supply is difficult. You have to have, number one, the storage on each end of the transaction to handle the material, and you have to have some transportation available to you. Most of the time, this is trains. The trains are not always easy to get your hands on, and in addition, the railroads are not always easy to work with. So while your market may be in a shortage condition, lining up the logistics that are needed to get the ash from the market that is in excess supply to a market that's short in supply is not a very easy thing to do. And again, it costs money, and sometimes that's a reason why the folks in the shortage end of the transaction don't want to pay the additional cost to get that the ash to that market. Secondly, we have quality, and as I alluded to a couple minutes ago, the combustion stream injections are the source of this problem. Primarily, when we see activated carbon and other things injected into the ash, it makes it unusable in some cases for concrete. So when we look at the hard numbers here, I took a 5-year period from 2015 to 2019 to show you what's been going on, and this has been going on for a long time. We do an annual production and use survey, and we've done so since 1968. In which we look at all the coal combustion products produced by these plants, and we go through the various beneficial uses. And right now, we're just going to focus on fly ash for purposes of today's discussion. But in the period of 2015 to 2019, we produced almost 186 million tons of fly ash. In that same period, we used almost 109 million tons of fly ash in all beneficial uses, not just fly ash in concrete, fly ash in Portland cement production, fly ash in geotechnical applications. In all applications, we used just under 109 million tons in that 5-year period. In concrete, we used 69.5 million tons of fly ash during that period. And we disposed of 77.2 million tons of fly ash. So clearly, our challenge is to identify what's causing us to go to disposal with that fly ash that is going into landfills and ponds right now, but the ponds are starting to close rapidly. We have, looking at that, we have 15 to 16 million tons of fly ash not being used annually. The challenge again is to capture that 16 million tons per year and get it into the concrete markets to the best of our ability. So there is a lot of material out there, even at the reduced production. Remember that during this period of 2015 to 2019, the natural gas segment of the market was capturing market share from coal. Coal was going down each year from 50% to 20%, 25%, somewhere in that range, and we still had excess fly ash going into disposal units. Looking forward at the next 20 years, roughly, we commissioned the American Road and Transportation Builders Association a few years ago to do a forecast for us. They updated that forecast in 2019 using 2018 as a base for their data and projections. And they showed the scenario that you're seeing on the screen right now. The most likely case is that over the next 20 years, we'll see the coal-fired production of fly ash to level out, roughly decline slightly to about 31 million tons. Worst case scenario, if everything falls apart for the coal-fired plants, we'd be dropping down to under 25 million tons. And if we got lucky and won the lottery, we'd see everything increase to 44.8 million tons. And there are things that could make that possible, things like carbon capture, use and storage, and things like that, and various combustion technologies. But that's an aspirational goal, I would think that would be fair to say about that. So that's what the ARTBA study shows, that we're going to be relatively flat over the next 20 years in terms of our production of fly ash. In looking at another set of data here, that same report said, well, let's take a look at where we were in 2018. And under the baseline forecast, the most likely one, again, we'd be declining from 36.2 million tons in production in 2018 to 30.8 million in 2039, a decline of a total of about 15%, or average of less than 1% decline per year. Again, if we won the lottery and we got everything that we needed to operate these plants to the best of our ability with coal-fired generation, we'd see that jump up, as indicated here, from 36.2 to 44.8 million tons of ash produced per year. And of course, the worst case scenario that ARTBA said we could probably anticipate would be showing the last line there, 36.2 declining to 24.9, a significant reduction, as you can see. The interesting line is the bottom one, that fly ash utilization, again, in all beneficial uses, is anticipated to grow from 20.1 million tons in 2018 to 27.8 million tons in 2039. And this takes into account just ash coming out of power plants. It does not take into account any ash that comes out of harvesting activities. So that's what we see coming out of the power plants and going to markets from that particular estimate by ARTBA. And their last couple projections they did for us were pretty close to being right on. So how about importing ash to meet market demand? And some people have said, yeah, there are countries that have excess quantities of ash that are looking to export that ash. Most of the export material is coming from China and India. Water transport for fly ash use in concrete mixers is very expensive. You just don't throw that into a ship and just send it out on the ocean. You have to have a very specialized type of transport, and that's expensive. And there's not many of those ships around. The other thing you have to have, of course, is terminal availability at both ends of the transaction. That's quite limited. And most of the time, those terminals are being used for cement, and they can be turned over much faster with cement in those silos than it can with fly ash. And finally, another barrier to imports is the quality of the imported material has to be watched closely. There have been some things that have come into the U.S. that have been represented to be one level of quality and turned out to be very disappointing later on when it actually got to the market. So imports really are not expected to be much of a part of the solution to closing the gap between supply and demand. But looking at harvesting, we heard a lot about harvesting this morning. Some folks say, well, where did this term harvesting come from? Harvesting, of course, is the term that's selected by consensus by the industry to describe the process of removing coal ash from disposal for beneficial use. And the reason that harvesting was selected as the term for this activity is that when you start getting into using terms like recycling, reclaiming, recovering, in certain parts of the country, you find regional or state or local regulations that attach certain requirements when you say, well, we're recovering a material or recycling a material or reclaiming a material. We couldn't find any place that addressed harvesting. So in order to keep ourselves away from some regulatory difficulties, we suggested and the industry adopted the term harvesting. Disposal, of course, of coal ash occurs in landfills and surface impoundments, also known as ponds. EPA has been after the ponds to close for quite some time now, and they're in the process of closing. But one of the problems is that when they started creating these regulations that dictate the closure of some of these impoundments if they're impacting groundwater above certain levels, is that they never took into account the opportunity for harvesting these materials for use in things like concrete. We did suggest that to them during the rulemaking in a meeting with the Office of Management and Budget during review of the rule. We said, hey, don't set deadlines too close together because this harvesting activity will take a long time. And they said, well, why would anybody harvest? And we explained it to them and they looked at us like we were from the moon. And we said, you guys really need to think about this. And they said, well, we don't have time to think about that. And when you talk about harvesting from these ponds, you have to remember a lot of these ponds have been in operation for decades, which means that it's going to take decades to remove the material if you're going to go into harvesting activities. And of course, that gets expensive as far as setting up the beneficiation equipment, whatever you're going to be using the ash for. If it's for concrete, that's going to be your most expensive. And we're going to need to have the cooperation of the utility or the owner of that particular pond for 15, 20, 25 years. And many utilities are just not interested in being in the recovery process for 20 or 25 years. That's just a reality of how utilities operate. They want to close these ponds as fast as they possibly can and get them behind them and forget about them. We're looking for coal ash in monofills, which means there's only one material placed in the disposal unit, so we can try to keep the beneficiation process as clean as possible. As you heard this morning, that's it's difficult, and a lot of these ponds are going to have other materials, particularly bottom ash, in there as well. The estimate we have made is that we have over 2.5 billion tons in disposal in the U.S. Our surveys going back to 1968 will give you a number somewhere between 1.5 and 2 billion tons. It's easily over 2.5 billion tons when you consider the decades that our surveys don't cover. So even if we could recover 10% of that 2.5 billion tons, that's a lot of fly ash and other materials. So in summary, closing up this particular discussion, there is fly ash being produced that is not being used. That one slide that I show you clearly shows that we're actually throwing away millions of tons of ash per year. And the challenge to the industry is find ways to capture that. Fly ash production is expected to remain relatively constant for the next 15 to 20 years. Imports will continue to play a minor role in meeting market demand. Harvesting will close or eliminate the gap between supply and demand in some regional markets. If you're in North Carolina these days, you are about to be in flush with the fly ash as Duke Energy gets 3 beneficiation plants going, which will add close to 1 million tons of production of fly ash to that market this coming year if they meet their targets that have been dictated by state law. Significant changes in specifications can help with alleviating the shortage in some markets. We've heard a lot about blending materials, and there's some great opportunities as were indicated today in the morning presentations. We need to take a look at what we have available in these regional markets and figure out what are the best opportunities to blend materials so we can have a consistent supply of SCM to meet the needs of the markets. And finally, the beneficiation technologies that are available out there to make concrete grade ash are available. They can be costly, and we have to be prepared to factor that into our business plans.